back to another lesson. Today's learning goal is I can factor polynomials in the form of ax squared plus bx plus c, including perfect square trinomials, and I can factor difference of square polynomials. So, we've already learned about the perfect square trinomials and difference of square polynomials, and we've learned that by multiplying certain binomials together, we can get perfect squares and difference of squares. We're going to be looking at that in the other way. We're recognizing them as polynomials and factoring them into the two binomials. So, starting with the difference of squares. The difference of squares refers to a polynomial in the form of a squared plus, or a squared minus b squared, or squared value subtracted from another squared value. Okay. If a polynomial begins as a difference of two squares, a squared minus b squared, we know the factors are a plus b and a minus b. So, first we have to be able to identify our perfect squares. Okay, so determine whether the following are perfect squares or not. If they are, write the term as a product of its square roots. So, 81 is a perfect square because 9 times 9 equals 81. 144 is also a perfect square because 12 times 12 is 144. X squared, well, x times x is x squared, so that is also a perfect square. 9x cubed, well, the x cubed, if we square root that, we would get a decimal there, so that's not a perfect square. 4x to the fourth, well, we have 2x squared times 2x squared gets us 4x squared, so yes, it is a perfect square. So here, when it says use the patterns above to factor the difference of two squares in 1 through 3, check your solution using multiplication. Well, here we have a perfect square x squared and a perfect square of 49. Notice how this has to be subtraction in the middle. It's very important that it has to have subtraction in the middle. There is no such thing as the sum of perfect squares so only the difference. So subtraction has to be. So here, the square root of x is squared is x. And square root of 49 is 7, so one of them is going to be x minus 7 and x plus 7. And if we were to FOIL this back together, that would be x squared minus 7x plus 7x minus 49. Those x squares go away, so we get back our original expression. Here, this one, the square root of 4b squared is 2b squared. And the square root of 25 is 5, so here we would get 2b squared plus 5 as well. Hence, here, number 3, the square root of 36 and m to the fourth is going to be 6m squared. Square root of 1 is 1, so our answer is going to be 6m squared minus 1 and 6m squared plus 1. As such. Sometimes you have to factor out a greatest common factor here before using difference of squares. So for example, number 4, we're going to have to factor out a 6 here. And then we have, when we do that, we have n squared minus 9. And then n squared minus 9, because both of those are perfect squares, becomes n plus 6, n minus 6. Same thing applies over here. We're going to have to factor out a 3. So we factor out a 3, and we're left with c squared minus 4. We have 3c plus 2, c minus 2. Go ahead and try number 6 out on your own. What you should have found is that you can factor out 2p, which leaves us 4p squared minus 25, which factors into 2p minus 5, and 2p plus 5, with the final answer of 2p times 2p plus 5 times 2p minus 5. So, perfect square trinomials, okay, are trinomials that have that can be factored into the same thing. So, a perfect square trinomial is the result of squaring a binomial and will have one of the resulting formats. Okay, so here a squared plus b plus 2ab plus b squared will factor into a plus b and a plus b, or a plus b squared. a squared minus 2ab plus b squared. If we have a polynomial that has this pattern, it's going to be a minus b and a minus b, or a minus b squared. Okay. So, is it a perfect square trinomial? These are the questions that can help you determine if a polynomial is a perfect square polynomial. Are the first and last terms perfect squares? Okay. If so, list the square roots. Are the middle terms twice the product of the square roots found in step 1? If the answer to both 1 and 2 are yes, the trinomial is a perfect square trinomial. So here it says try to figure out whether each polynomial is a perfect square or not. So we're going to take the square root of a, which is 2x, the square root of c, which is 5. And if we do that, we get 2 times 5, which is 10. But we need to double it, so that would be 20x, and this is not 20x. So therefore, this is not a perfect square trinomial. Here, the square root of x is x. The square root of 81 is 9. And 2 times 9 plus times x is 18x. So therefore, this is a perfect square trinomial. Okay. For c, here we can factor out a 2 first, so let's do that. That leaves us with x squared minus 13x plus 72. And with that, 72 is not a perfect square, so therefore this is not a perfect perfect square trinomial. For letter D, well, obviously it's going to be, but this is going to be 4x. Square root of 16x squared is 4x. Square root of 9 is 3. 4x times 3 is 12. 12 times 2 is 24. So therefore, this is a perfect square trinomial. Now, knowing that, here we're going to take a look at these 4. Here we have x squared plus 26x plus 169. Let's take the square root of both of these. This is 13, and this is x. And as a result, x times 2 times 13 is 26x. So this is a perfect square trinomial. And because this is a plus sign right here, it's going to be x plus 13 squared. In number 8, the square root of this is 5x. The square root of this is 6. And 5 times 6 is 30. 30 times 2 is 60. So this is going to be a perfect square trinomial. Since we have a subtraction right here, this is going to be 5x minus 6 squared. Here we have x squared minus 29x plus 100. This factors into x. This factors into 10. And 2 times 10 times x is not 29, so we're just going to have to factor this using grouping. So that means we're going to have to find, or we can just factor it by figuring out what two numbers multiply to 100, add up to negative 29. Well, we get negative 4 and negative 25. So that gets us x minus 4, x minus 25. Finally, this one is 3x when it's square root, and this one's 7. 3 times 7 is 21. 21 times 2 is 42. So this is going to be perfect square trinomial of 3x minus 7 squared.